KVL in AC circuits. Kirchhoff's voltage law was developed in 1845 by Gustav Kirchhoff, which is the sum of all voltages around any closed loop in a circuit is equal to 0. AC circuits have a sinusoidal behavior, and as we can see here, that the vectors are represented in a polar or rectangular form. It can be seen in this circuit that we have 3 AC voltage sources and 1 resistor all placed in series, and we should find the voltage drops across R1 in the circuit. The vector of each of these source voltages can be represented as shown. Each of these are given in polar form with the magnitude and angle from the x positive direction. The law of vector addition must be used to add vectors. When adding vectors, the x direction and the y direction must be determined. That means you should transfer from polar forms vectors to rectangular form. Sine and cosine identities must be used in order for us to solve. The sum of the source voltages must be equal into the voltage dispatched by the resistor in the circuit, and this is shown down, which is V1 plus V2 plus V3 is equal to VR1. To find the resultant vector, the x and y component can be summed to give the resultant into rectangular form. Finally, the rectangular form vector can be transformed to a polar using Pythagoras theorem and the tangent identity. This gives us a final result of 32.416 acting on 8.233 degrees from the positive x direction. Thanks.